All right, Olivia, this is 4-1. We're starting chapter 4. We're doing reflections today. Homework is these guys. 1 through 4 and 6 through 14 evens. Did you guys get this written down?
Yeah.
1 through 4, 6 through 14 evens. It's not a whole lot of problems, but whatever. 2 examples, but I'm going to start over here, and let's do this first. We have talked about reflections. Write this down off to the side. Reflections. We talked about reflections in like chapter 1. We glanced over it briefly. And when we reflected things, we reflected over the x-axis. We reflected over the y-axis. And then I don't think we did this in chapter 1, but we're going to reflect over the line y equals x. And we'll talk about what that looks like here in a second. Okay? So those are the 3 types of reflections that we can do that have special, like, procedures to them. Okay? Got it?
Brian, have you seen A Christmas Story? The movie with like the gun, like you'll shoot your eye out. You know? He looks like
I never thought about
the mean
okay,
kid.
now the one that's like,
Yeah.
yes, yes. What the heck?
I haven't seen it.
You haven't seen it?
But you know that.
Who are you dressed
And I
up
know
as?
that. I haven't seen it. I know that's why. And you're just.
All right. So whenever we're talking about reflections and we're trying to establish the rule, I guess I always pick the 0.23. If I take that 0.23, boys, are you listening? If I take that 0.23 and I reflect him across the x-axis, which means he goes down, what will the coordinates of him be? What? 2, -3. So if you're going over the x-axis, what's the rule?
X, Y, negative Y.
X, -y. The y becomes negative, yeah? Do we remember that from chapter 1? Or whatever chapter we had first, right? If I take that point instead, 2, 3, and I reflect him across the y-axis, which is over here, what will his point become? -2, 3. So what's the rule for over the y-axis? Negative xy. Okay, now, we maybe have seen those guys before. Now we're going to talk about the line y equals x. So I'm going to erase this. I'm going to erase this. All that's good stuff, okay? The line y equals x is a linear function. This is like y equals x plus 0. If you graph y equals x plus 0, you start at 0 and you go up 1 over 1, up 1 over 1, up 1 over 1, and he does this thing, right? That's the line y equals x. It's a linear function, okay? If I'm going to take this guy, where are all my colors? Where's my purple color? If I take this guy and I reflect him across that line, do you know where he's going to go? Like somewhere down over here. Do you see that? He's just like flipped over that line. Do you know what his coordinates will be? If you had to guesstimate. 3, 2. So do you see the rule? If I flip him across this line y equals x, the y and x just flip places with each other, right? So the rule is y, x. None of them are negative. Just flip them. And that's the rule when you flip them across that line y equals x. That's that dotted line, that 45-degree angle line. You just flip the coordinates. Got it? Okay. All right, now they're going to do one more thing to you. And they're going to say instead of having across the x-axis exactly, across the y-axis exactly, across the line y equals x exactly, which have like special rules for them, let's say in example 1 that I want to flip this thing across the line y equals 1. Negative 1, I'm sorry. Y equals -1. Okay, if I graph the line y equals -1, do you know what he looks like?
Up and down. It just hits.
You go to -1 on the y-axis. -1 is right here because we're going by 2's, right? And he has a horizontal line straight across. That's at y equals -1. You see him? Okay. Now, there's no real special rule to these guys other than the fact that, like, you got to do the opposite. So, like, R is 2 units away, 2 units above that line. So if I'm going to flip him over, I'm going to go 2 units below that line to find my new R. Does that make sense? Okay, he's going to be down 2 units. Okay, but we don't call him R anymore. We call him R. What?
R prime.
R prime, yeah. He's got like a little tick mark on him. R prime, that's where the new guy is. Got it? S is, let's see, S is 1, 2, 3, 4, 5 units above. So I'm going to go 1, 2, 3, 4, 5 units below. That's where S prime is. Okay, or from R, you can just go down 3 more, right? R and S are 3 units apart. Okay, I'm going to find V now. V is 1, 2, 3, 4 units above the yellow line. So I'm going to go 1, 2, 3, 4 units below the line. That's my V prime. Okay, T is 1 more unit besides that, so T prime is going to go there. And if I connect my dots, this is a little bit hard to look at because they're going by 2s. Is that hard to like see? Yeah, now that they're going by 2s. So this yellow line right here is where your mirror should be. He's like flipped across there. He's the same distance on the bottom as he is on the top. Does that make sense? Okay, and there's no real special rule to that. Like I can't just add coordinates to the X's and add coordinates to the Y's, whatever. It's just the way that it is. Got it? So let's write out our coordinates for R. What's R prime coordinates? 2, negative 3. S prime is at 2, negative 6. Okay. T, 5, negative 6. Yep. And V is at 5, negative 5. Perfect. There's my new coordinates.
Well, I guess it depends on where you move in this case.
Yeah.
or the
So you could figure it out. Yes, all your X's will stay the same. So on your, if you're flipping it across the line Y equals negative 1, all your X coordinates should stay the same. Like 2 and 5 and 2 and 5, those guys should not have like moved from the original to the new one, right? But these guys are going to go like different, right? Like S was originally at like 2, 4, and now S is at 2, negative 6. Okay? The distance from 4 to negative 1 is 5, so I'm going 5 more to be negative 6. Does that make sense? So you could maybe figure it out without doing the graph, but it might be a little bit harder. All right, this one, we're going across the line X equals negative 2. Do you know where that's graphed? Negative 2 on the x-axis is right here, and he's going to be a vertical line this time. And I'm taking that guy and I'm flipping him over. It was really hard for the morning group to see this, knowing that this y-axis is here, so pretend he's not there. Right? Now you're flipping it across that green line. So S is 1, 2 units this way, so I'm going to go 1, 2 units, and now your S prime is there. Right? Do you see what I'm doing? T, I'm going to go T off of S, so T is 1.5 more, so T prime goes there. Do you see that? R is 2 units that way, so I'm going to do 2 units this way. This is R prime, and then V is right below T, so V prime. And this is what he looks like. Okay? Good? He's flipped over. Let's do the coordinates. R prime is now at negative 6, 1. Is that true? S, what's he at? Negative 6, 4. V, or T, let's go T next. Negative 9, 4, and V is at negative 9, 3. Okay, so in this case, because we're flipping across the x-axis, the y's shouldn't have changed, right? Like 1, 4, 4, 3, those stayed the same as 1, 4, 4, 3 over here, right? Okay, it's just the x coordinates moved. Okay, got it? All right, last example. We are reflecting on the line y equals x. Okay, Winona is designing a logo for her blog header. She designs a figure on the coordinate plane and wants to reflect it across the line y equals x to complete the basic shape. Which one's the original, the green or the blue? How do you know the blue's the original?
Because I don't know. Because green has D prime.
The green has the primes, right? The primes are the second ones. Do you see that? Okay, so we're starting with the blue and we're flipping him and making him the green, all right? So if I take A here and I flip him across, he's going to become A prime. If I have B here, he's going to become B prime, right? Okay, so they have listed out all the coordinates, A, B, C, D, E. Those are the original coordinates. And when you're flipping across the line y equals x, x, y just becomes yx. They flip places with each other, right? We said that from up above. Okay, so they said 1, 8 becomes 8, 1. Yeah? They have E done for you. 2, 2 becomes 2, 2. He stays 2, 2, right? Okay, A is going to be, or A prime, becomes 1, negative 2. Yeah? Okay, what about C prime? 4, 1. And then D is 4, 4. So if you notice like C and D and E, they were on that line, they're not going to flip, right? Like they're on that place. They're not going to change places. Okay? Good? Got it?
Yeah.
Not so bad? When do you do these? It says graph the image and then determine the coordinates. So if you want to do this, like A, B, C, and list the original, that might be a good idea. A is at -3, 2. B is at 0, 1. C is at -2, -3. And then you're flipping across the line y equals x. So then you'll have to list out what those coordinates are. So you have to graph them and then list the coordinates. Okay? That's for number 1. Number 2, you're going across this line, so you're going to need to graph that line. Do you know where x equals -1 lives? Yeah? -1 on the x. Boop, like that. Okay? Number 3 is going across that line y equals x again. And then number 4 is across the line y equals -2. So there he is. Okay? Graph him, list the coordinates. Not so bad. One thing to keep track of is that when you're flipping him, he should stay the same shape and the same size, but just be a different orientation, right? So if your shape does not look the same, you didn't do it right. If he's not like the same size and shape, he's not quite right. Okay, so keep that in mind. And then you have to do 6 through, I don't know, 14 evens or something like that. Do you guys need graph paper?
Yeah.
Yes, I'll give you some graph paper. Okay? Good? That is all. It's kind of short. All right, goodbye, Olivia.